The next rule we want to talk about is the quotient rule. So what if you were given a function that instead of it being u times v is u over v? The rule would be to find the derivative would be u prime v minus uv prime all over v squared. Notice how it's very similar to the product rule. The product rule was u prime v plus uv prime. Notice the order is the same. There are many different rules and ways to express the product rule and the quotient rule. It's like the same rule, but they express it differently. I like this expression because the order is the same. And that's important because if you reverse the order in the quotient rule, it's going to be wrong. If you reverse the order in the product rule, no big deal. But in the quotient rule, it's a wrong answer. So if you memorize it, the product rule as u prime v plus uv prime, and you remember the quotient rule is the same thing, u prime v minus uv prime all over v squared. So remember the quotient rule has a minus sign and it has to still be a quotient. And the denominator stays the denominator, just square it. So we're going to use the same technique that we did before in the previous questions. We're going to identify our u, our v, our u prime, our v prime. So u is 4x squared plus 3. V is 2x minus 1. U prime, 8x. V prime, 2. The derivative is u prime v minus uv prime all over v squared. So that's going to be 8x times 2x minus 1 minus u. Notice how these parentheses are so important. V prime all over v squared. Do not go crossing out. Remember, you can only simplify or factor if it's factors, but you don't. You have subtraction there. In order to clean this up a little, we distribute through and we can get a nicer answer. So if we come up here, and I push them up here, the derivative becomes, distribute the 8x to both, 16x squared minus 8x. And if I think of this as I'm negative 2 distributing through, I get a minus 8x squared minus 6 all over 2x minus 1 squared. 16x minus 8x is 8x squared minus 8x minus 6 all over 2x minus 1 squared. And that is your derivative of a quotient. We're going to look at some 3 examples now where you don't need to do the quotient rule in order to find the derivative. And usually this occurs when your u and your v, if one of them doesn't have a variable with it. So notice that your v here has just a constant term, 5. So when you do the v prime, the derivative of a constant is a constant, it's going to be 0. I mean, so derivative 5 will be 0, and then one of your terms are going to cancel out. So if we did the quotient rule, you'll still get the right answer, just with a lot more work. So my advice to you is if you're in that case where you find that maybe the u or the v ends up being a constant term without a variable, try a different technique, such as the one I'm going to show you now. So technically, if you think of this 2/5 is the coefficient. So really, f of x is 2 over 5 x to the third. So if you take the derivative of that, that becomes 3 times 2, 6 over 5, x squared. And you're done. That's your answer. Now, but if you did the quotient rule, this would have been your u, that's your v. Your u prime would have been 6x squared, and your v prime would have been 0. So the derivative would have been u prime v minus u, sorry for the squishing, v prime, 0, all over v squared. So that gives you 30x squared minus 0 all over 25. And then that 0 is not important. 5 goes into both of them. 6x squared all over 5. Notice how much more work that is. So my advice is don't do that. If your v ends up v prime or your u prime ends up being 0, there's got to be a simpler way. Don't do the quotient rule. Notice here, same thing. Your u is just 4. Your v has a variable with it, so you could do it there, but not with u, because the derivative of u prime will be 0. So I'm telling you instead to think of this as x to the negative third with 4 over 7 as the coefficient in front. So the derivative will be negative 12 over 7 x to the negative fourth. And if you did the quotient rule with the original expression, you'll still get the same answer, but with a lot more work. So again, try, if you have your u or your v as just a constant term, try not to use the quotient rule. It's a lot quicker and cleaner. In this case, though, in C, notice that it's not that you have a constant term in numerator denominator, but what you do have is a monomial in the denominator. Monomial, one term. If you have a monomial in the denominator, you can divide it into both terms before you even take the derivative, and it actually makes it a much easier question to work with. It's similar to ones when we did some examples we did when we first talked about derivatives. So this becomes 5x over 4 minus 3 over 4. Did we take a derivative yet? No. All we did was simplify. So the derivative is now derivative 5x over 4. Remember, that's the derivative of x to the 1, so it's just the coefficient in front. And the derivative of a constant is 0. So notice what the derivative turns out to be. Just 5/4, which is great, but if you did the quotient rule, you'd have a lot more work to do. So just be aware, if your u or your v is a constant, try not to use the quotient rule. Or if your denominator is a monomial, try not to use the quotient rule. So monomial or quotients or constants. Monomials or constants, there's probably a quicker way than the quotient rule.